let's do another polynomial regression. So the first thing I want to do is try to determine what degree of polynomial I'm dealing with. So let's start doing finite differences. To go from -1 to 3, I would go up 4. To go from 3 to 3 would be 0. 3 to 5 would be +2. 5 to 15 would be +10. And 15 to 39 would be +24. These are not constant, so this one is not linear. All right, let's try this again to see if it's quadratic. From 4 to 0, that is down 4. 0 to +2 is up 2. 2 to 10 is up 8. And 8 to 24 is up 14. This is not constant, so it is not quadratic. Okay, let's go again. From -4 to +2 is up 6. From 2 to 8, up 6. 8 to 14, up 6. So since it took us 3 times out to get a constant term, this must be an x to the third polynomial, so this one is cubic. So when I put this in the calculator, I'm going to use cubic regression to get my equation. So let's go back. Let's practice putting this in the calculator. So I have the list from last time in my calculator, so I want to change the list. So I'm going to push stat, which is right by the arrow, and then I want to edit my list. 1. And now you don't want to hit clear. You want to just go get on each one of these numbers and hit the delete button, which is by an arrow. If you get on top of the L1 or L2 and hit delete, you'll delete the whole list and you won't have it there to type numbers in anymore. If you would happen to do that, you'll have to Google it to get the list back. Okay, so I've got 6 terms here. So my list 1 is going to be 1 through 6. And then I need to put the output values for each of those. So at term 1, it's -1. Term 2 is 3. Term 3 is 3. Term 4 is 5. Term 5 is 15. Term 6 is 39. So now I want this to calculate the regression formula for me. So I'm going to go back to stat. And this time I want to ask it to calculate the regression formula. So I'm going to calculate. And we found that this one was cubic, so I'm going to go down to the 6th option. And I used list 1 and list 2, so I'm going to keep that the same and go down and hit calculate. So this tells me the number in front of A needs to be 0.861111. Number in front of B is this, C is this, and D is this. So I can get the cubic of best fit by putting 0.86x cubed minus 6.8x squared plus 18.04x minus 13. And that would give me my cubic formula for this particular set of data.